Chapter 22 deals with intravenous calculations, and previously we discussed how to calculate the flow rate when using an infusion pump. However, there are cases where an infusion pump is not available and the nurse must manually regulate the IV flow rate with a flow regulator within the tubing. So the question is raised, how is the flow rate actually measured? The flow rate is measured in drops per minute, or GTT per minute, which is determined by the type of IV administration tubing. There are two types of IV tubing that we will discuss used to determine IV flow rates. The first type of IV tubing that we will discuss is called a macro drop. This is the standard type used in delivering large volumes of a specific solution. In addition, the measurements for possible drop factors are 10, 15, or 20 drops per milliliter. For our purposes, we will be referring to 10 drops per milliliter. The second type of IV tubing is called a microdrop. This is used for dosing pediatric, small children, and geriatric older adults. In addition, the measurement for a microdrop is 60 drops per milliliter. When using infusion pumps, we can use a standard dosage calculation to determine what the flow rate is. However, if we are manually calculating the flow rate, we actually need to use the standard equation to determine what the flow rate is. The equation is X equals the amount of solution times the drop factor, all divided by the time. The amount of solution is measured in milliliters, the drop factor is measured in drops per milliliter, and then the time is measured in minutes. So the final answer will be drops per minute. We will go through two separate examples to show how to apply the formula to determine the drop factor when we are not using the standard infusion pump. Example 1, we have administer D5RL at 75 milliliters per hour. The drop factor is 10 drops per milliliter. So we're going to start by substituting all of the known values into the equation and solving mathematically. So the amount of the solution is given as 75 milliliters. So we're going to fill in 75, and again it's measured in milliliters, times the drop factor, which is 10 drops per milliliter. So we have 10 GTT, or drops, per milliliter. And this will all be divided by the amount of time. And the time is given as 1 hour. Considering the measurement needs to be in minutes, instead of writing 1 hour, we're going to write 60 minutes. So from here, we see that this milliliter is in the numerator and this milliliter is in the denominator, so these two actually divide into each other. So multiplying 75 times 10, we're left with 750 drops, still divided by 60 minutes. Using division, we get 12.5, but in the lecture that we had previously, we talked about the fact that whenever we have the final answer, it needs to be rounded to the nearest whole number. So our final answer is X equals 13 drops per minute. Using the exact same formula, we're going to go through example 2. Administer D5 half NS at 30 milliliters per hour. The drop factor is a microdrop. Earlier, we talked about the fact that whenever you see microdrop, you automatically should think 60 drops per milliliter. So we're going to fill in the known values that we have, starting with the amount of solution, and here the amount of solution is 30 milliliters. So we have 30 mils multiplied by the drop factor. Whenever we see microdrop, we're going to automatically think of 60 drops per milliliter. So we're going to fill that information in here. And then we're going to divide that by the time. And again, we are working with 1 hour, which we will represent as 60 minutes. So the milliliters divide into each other. And here we have 30 times 60 GTT all over 60 minutes. But instead of multiplying 30 times 60 to get 1800, we see that we have a 60 in the numerator and a 60 in the denominator. So those will divide into each other, leaving us with x equals 30 drops per minute as our final answer.